In this video, I would like to continue the discussion that I started in the previous video on the differences between computing domain problem and the application domain problem, and also add on some of the issues that I could not discuss in that video, in the previous video. Right. First, I would like to look at or to discuss, given that you have now clearly understood the differences between the computing problem and the application domain problem in terms of research, and you know the roles between these problems and their solutions in your project. How now do you state or do you write down your problem, right? But before that, you will notice that this diagram has been enhanced a little bit by adding literature node on both sides. Remember, I said literature, you may be able to find the gap in the literature, but even when you find a solution, you need to go back to the literature to allow you to review your contribution with respect to literature and clearly demarcate how far your contribution goes. So to do that, you need the literature as well as the application domain solution, right? Remember, I said in the past video that once you find a solution in the computing domain, you evaluate it by using it to solve the application domain problem to get a solution, and that solution, the quality of that solution will inform you to the various limitations of your contribution in the computing domain. And of course, you do need to specify how far you went, what aspects of the problem did you address, and also part of that would be part of future work, and also other researchers may pick up where you left off and continue the research. So the literature plays an important role in both the problem and the solution to the computing problem. With respect to the problem, when you say, oh, we have this problem, you must be able to have some people around the world in the literature who agree with you that it is a problem. So the research review that you do when you are trying to establish a problem is different from the main aim is simply to confirm from the other guys that you are indeed there is a problem. It's not a good sign for you to state a problem and you are the only guy in the room who sees it as a problem. In other words, your researcher, especially if you are working with a senior researcher, they will be a bit uncomfortable for you to simply say there is a problem, and you can't find even a body of literature that confirms that is that because a lot of people have done research, and if they can confirm after having done their research that there is a gap in this area, then that's a true gap. That's how we know that it's a gap and it's worth researching into, right? But then when you find a solution, you need to go back to people who addressed similar problems and say, okay, this is how far they go. My solution, you now compare your solution and assess its impact. Now that there was a gap in the literature, you now go back to the literature and confirm that this gap, how far this gap has gone to be filled by your contribution. This is where you also delimit how far you went so that other people can take off from there, right? On the application domain side, although I said the application domain problem plays some role with respect to your computing research problem, it usually inspires, it's a motivation, it motivates it. And sometimes it triggers the research, and then you need to find the based on from there. So it serves two roles. The second role is where you now, when you are now have found or come up with a solution to your application computing domain problem, you now want to check whether it works in real life, and then you apply. So in the evaluation of your solution to a computing problem, you have to apply it to application domain problem and find a solution and clearly work out how far your contribution goes, right? The literature also plays an important role, because you can't go and say, oh, there's a problem in this domain, and you are again the only guy in the room who says that. So more or less, you need to use the literature in both the problem and the solution to see how far you have solved the problem. Does that make a difference in the domain? What is the impact? But then that's not your research, isn't it? You don't devote a lot of time to that. You devote a lot of time to the computing domain, because that's where your research lies. When someone asks you what exactly are you researching about, you don't normally talk about the application domain problem. The way you say it will determine where you fall. You should fall ideally in this community. We are a computing research community, so our research problem should fall solely in the computing domain problem. And sometimes you should be able to say it without even mentioning the research problem, unless someone says, okay, how do we know that your contribution works? And suppose you have S1, so what? How does that change the world? Then you say, we'll be able to solve problems like, and then you state the application domain problems, right? That's one. In a way, I've recapped what the problem is and what the role of literature in all these scenarios. This is why literature is very important. You need to do literature review throughout your project, and it's important also in assessing and evaluating your problem. Uh, it's important even in the application domain. It doesn't have to be a trivial problem. It has to be a problem that has impact to the people. Indirectly, the impact that application domain problem has will also imply the impact of S1, because S1, if it can lead to the solution of that high impact problem in the application domain, then your contribution will be further appreciated, to be further evaluated, to be of significance. So that is so this diagram is more or less symmetrical. Although it's symmetrical like this, your work is largely in the computing domain. That's why what I want to emphasize. And right, at some point, now let me take you back to one of the recording that I made relating to how should what makes up, what are the components of a research problem. And I expressed this in terms of X, Y, and Z, right? In terms of X, Y, and Z, right? One may ask, okay, in terms of this particular diagram, what is X, Y, and Z? Well, I said X is what what you are investigating, and Y is possibly the something that you will be able to do once you find a solution. In other words, it is an embodiment of the solution. And then Z is obviously the application domain. So in your case, you want to, when you state your problem, you are saying you are investigating P1, right? So that you will be able to once you solve P1, you will get a solution that will enable you to do something. That something will then allow everybody to solve the domain problem like P2. So in a way, X is P1 and Y is S1. What you will be able to do when P1 has been, when you now get S1, and Z will be, of course, the application domain, which means it will be P2, so that you'll be able to solve problems such as P2. So, so that explanation is consistent with this, because P2 is important, because it's now, it implies the significance of addressing P1 in order to find S1. It's important to do that because you'll be able to solve the problems in P2, although those problems are not really your your main research area, right? In the previous video, I also mentioned that most of you tend to spend time on P2 and S2, and it's understandable. Most junior researchers have that problem, and they go into doctoral research without knowing this diagram. Sometimes you'll be surprised. Some people finish their PhD without being able to distinguish or to clearly portray this diagram in their research. And therefore, when they also train some of their doctoral students, they might also not be able to pass on this knowledge. Even when I was doing my PhD, my supervisors did not necessarily present it in this manner, although they did. They were always emphasizing to me that the problem you are investigating really is in computer science, so don't present your work. So they didn't even communicate it properly. It is after my own thinking when I decided to, go deeper into this and appreciate what they were trying to tell me without expressing it probably in the way I have expressed it here. Um, so most of the time when I am supervising PhD students, I always have this image in my mind. And even when I assess your problem, I always have this image in my mind and try, when you say your application domain problem, I want to be able to appreciate what exactly in computing you will be doing and what is the significance. I could see, sometimes I do see, yes, there is a problem in the application domain, but the point really is what then is the computing research problem. And that's how I would assess any research in the area of computing. So for now, the question comes is, how do I write my research proposal? When you are writing your research proposal, it's possible to clearly state P1 and clearly state P2, but make sure you explain the role of P2. P2 is only for evaluation, right? It's only an application of the solution to P1. And it is important to then, in your methodology, say that when I find a solution to P1, I will evaluate it. There is an evaluation phase in your project where you will try to address the challenge posed by P2 by using S1, by applying S1 to the problem, and then assessing how S1 performs in helping to solve P2 and find S2. And when you do that, you need to find the limitations. Sometimes the limitations of S2, those that arise from S1, should be clearly stated, and then you discover what are the limitations of your problem and all that stuff. So from a methodological perspective, P2 and S2 play an important role in that case. So your research problem can state all these P1, P2, and also state the role of S2 in evaluating S1. But it is important that you don't tell us what S1 is, because you have not done research. At proposal stage, I don't expect you to have a clear idea of what S1 looks like. If you do, it's a good sign that your research is not a research project. Right? It's a good criteria to to show that S1 is not known yet. And this is usually the case between you and your supervisor, even your supervisor. should not have a clear idea of what S1 is. They may characterize it to say, once we solve problem 1, we will be able to know that we have solved it. That's what your supervisor and yourself would have a pretty good idea to say, okay, if we find S1, we will know how to check that it is a valid contribution. Some of you have been presenting research proposals where both P1 and S1 are known, and you actually state them. I'm sure you have seen me at some point asking, is it true that P1 is this, and is it true that the solution you have stated is this? And they say yes, yes. Right. In that case, you have a problem and you have a solution. So there's no project. Yeah, there's no project. The fact you have not implemented it in the application domain is not a research problem. Someone else can do it. You can then give P1 and S1 to somebody else who can then implement it. Or you can do it, yes, but then that's not a research project. Don't assume this is an example of an assignment for students whom we want to master the elements, the basics of technology. And we give them P1 and S1 already, and then say realize it in the application domain to say solve P2 and S2. So in most cases, we give students both P1 and S1, but we don't give them any implementation of it. Right? That's a undergraduate assignment where we are emphasizing on mastering the basics of the domain. So for you guys, we don't expect you to have a clear idea of what S1 was. The reason why you are making the research is because we don't know it. It's a contribution that doesn't exist yet. The same with S2. We can clearly tell at the point of your proposal that if we find S1, we will be able to evaluate it by solving P2 to find S2. But S2 obviously should not exist as well. You should not have a clear picture of that, because currently it is a problem that cannot be solved. P2, because we don't have S1, we can't do P2, right? We can't solve P2. So S2 is none. So at your proposal stage, we need to know that you have identified the body of literature, you have found P1, right? With respect to P2 also, we know that P2 is a problem. The literature says so. The experts in industry are saying so as well. So you can clearly say that we have a problem P1, and if we are able to solve it, we should be able to address P2 anyway, right? Especially once we find S1. But S1 at that stage is unknown. So when I'm listening to you, to your proposals, or reading your research proposals, you should not be able to tell us what S1 consists of. Don't go on to say, we'll be doing that. Some of you even say, okay, I'm solving P1 and I'm using a blockchain, right? If you think you will be using blockchain, don't say it, because it's a solution, isn't it? You might want to say, okay, we'll investigate a way to make sure that you define what, not how. The moment you go to how, you may encroach into the area of S1, and you may know what S1 is going to be like, right? But yes, there might be some times when you could specify the general area of technologies that can be associated with S1, but without knowing exactly how you want to do it. So there are circumstances where we may allow you to give us a general sketch of the framework, the context in which S1 will operate, but not the actual S1. In that case, yeah, there are projects like that where the fact that P1 should be a problem that could be stated in a way where you don't mention any aspect of S1, because we want it to remain open, because sometimes your findings in trying to solve P1 indicates that it's more efficient to do it in another way, not necessarily using a particular technology in your mind or a technology that you like. So it is important to realize that we need to know that. So this diagram is very important to someone. You need to keep it in mind as you go through your work, as you go through your project, particularly at the beginning when you are defining your research problem, and be able to have it always in your mind, right? It's very important for us as a community to keep this diagram in mind, and as we discuss, the reason why it is important is because when we make a contribution in the computing domain, the application domains can be many. We could just pick one in your project, but ideally, S1 will be a beautiful solution if it can apply to more than one application domain. So that characteristic is important, and you need to, when you write your thesis, for instance, you could say, while we are applying S1 to P2, there are other P3, P4, P5 that where this S1 can also be applied, and you could give examples and insight into how you might go about it. This shows that S1 is really beautiful. Beautiful in that it's generic. It's generic in the sense that it can be applied to more than one domain that are apparently different. So that will give you a general um, impression that, of course, if you just have to demonstrate in one domain, that's enough, because it may not. Sometimes solving P2 can be fairly complex and time consuming. So you show in at least one area that this one works, and you can give just simple discussion in your discussion section. You could then say, oh, although we have applied to P2, it can also be applied in this particular area. But some people who want to to be complete, for purposes of completeness, they might want to apply another P2, P3, and then they apply S1 as well, and then they compare the performance of S1 in P2 and P3, right, in two application domains or more. So you do that if you have time and probably the resources to do that. But generally, for a doctoral degree, it's enough to pick one application domain and show that this works. And you pick one that shows the limitations, that could clearly demonstrate that all we as S11, it's a significant problem, and it is functional, and two, it has got some limitations, and you clearly mark them for people who want to continue with the research or something like that, right? So I hope this clarifies the way of thinking about your problem and how you may state it with this diagram in mind. Right. Now, I would like to address that the one problem that you will find, although we have this way of looking at our research problem, when you write research papers are targeted at specific publication venues like journals, conferences, and all that stuff. These people will have a focus of their own, which have nothing to do with your project, because they don't define their themes, what the topics they are interested according to your project. So when you write research papers, it is you match your paper to the target audience, and that target audience may not really be interested in your computing domain. Sometimes they may be interested in the application domain, so you write your paper from the perspective of the application domain and show what is your role, your research plays in that particular application domain. That's the whole point. So research papers publications can be misleading. They are not written according to this structure. The reason why we do that is because the journals define what they want, and we try to write something they will accept. So research papers are more like research politics, where even funding applications, they may want something, and you believe your research can qualify. So you write your problem again, but emphasizing aspects of your project which appeals to the funders, right? So it does not, when you are applying for funding, you can blow up the application domain aspect, because that's what they want to hear, isn't it? You want to win funding. And sometimes they do focus on your computing domain. And if that is the case, fine, you present it that way. So when you publish, sometimes you may focus on S2, even though your project is focusing on P1. You may focus on P2 and then write a paper that way. And sometimes you write on P2 but emphasizing the evaluation of S1, right? So that it depends. When we publish, we are now free to do what we want, because we both have P1, P2, S1, S2. It depends. Sometimes you can do a literature review focusing on L2, and sometimes you do a literature review focusing on L1. L1 is the literature that is related to the computing domain. L2 is the literature that is related to the application domain. In fact, you are encouraged to do that, to write a review, literature review for L1 and also for L2, and publish. You find us doing that all the time. If you look at our publications, they match more, not our research project, but more the guys who are reading the paper, the target audience. So when you are targeting your audience, you shift focus within this map I have drawn here on the diagram. So when you are reading a research paper, it's also possible they always betray where the actual research project is. Yeah. So it's important for you to know that. That is always the case. Um, I want you to keep that in mind when you read the literature. You might know. In fact, I always know, for instance, that these guys are researching in this, but because the audience and the journal paper is interested in this area, they then wrote a paper that emphasizes those aspects and so on and so on. So you as you become a mature researcher, you begin to detect these aspects. You have this map in mind, and you know how these guys wrote a paper to satisfy a conference, because that conference has people who are interested in this area. It's good to go to conferences that addresses P2. It's good to go to conferences that addresses P1, and so on and so on. So when we write research papers, we choose on them on this map where we want to, which part we want to blow up according to P1, P2, S1 and S2, L1 and L2. So it depends on how we want to do it. So normally when we are at the early stages of our work for a research student, if I'm happy with P1 and P2, I will always ask, okay, could you write a literature review, which in your first year, as a first step, to focus on L1 and then focus on L2, so that by the end you are clear of the two domains, and after that you now want to proceed to address specific aspects of P1, do experiments, collect data, and do whatever is required until you reach S2. When you reach S2, you may want to again write another paper for L1, and also when you solve P2 and P3, you may also want to write a paper about P2 and S2, and include L2 as well. So all these aspects need to be addressed, but you know your thesis will be about P1 and S2, and P2 and S2 are only methodological, but they may be of interest to journal papers, to conferences, and all that stuff. So you just go there and talk to people along those aspects. So it is important to understand this when you read research papers, right? Uh, those are this is one of the important areas that I would just want to emphasize. Um, Now, let me comment a little bit more about when the government, our institutions, the tech hubs, they are all trying to put pressure on you guys in the country to say, okay, we want research that leads to something that can be commercialized, that can be patented, right? There are patents in computing, yes. So you need to do research, cutting edge research in computing that can lead S1 to be patented. So S1 can be patented. sometimes S2 can also be patented, right? So that whole space is rich in that. So if you focus on only P2, S2, you will sometimes never reach a stage where you can patent, because your P1 and S1 are not strong enough. They are not strong enough. They are not cutting edge. If you focus on P1 and S1, you are likely to come up with research gaps which don't exist in the world, and therefore your solution can be patented. You can patent S1, you can go further and even patent S2, which could be a product that is used in a particular application domain, and also commercialize that aspect. S1 can also be commercialized. If you can commercialize S1, that's powerful, because it can then be used by various application domains. So that's where we want to innovate. In computing, in our tech hubs, we want to focus on S1 and see if we can commercialize S1 without necessarily worrying about the domain. This means S1 can be applied in banking, agriculture, and all these other areas. Then can focus on S1. So if we continue with what our community, the confusion in our community, where we focus on P2 and S2, there will be no innovation with respect to P1. Innovation is in C1, in S1, and S1 by nature is generic. It can be applied in many domains, and that is very important. A typical example, for instance, is a project, for instance, that tries to use unsupervised learning to detect fraud, right? Detecting fraud is just a general problem of detecting an anomaly, and an anomaly that can be discovered using unsupervised learning is generic. It can be found in almost any domain, right? You can apply it to medical images, right? If you to detect cancer, you can apply it to banking fraud, to detect anomalies in the data. You can apply it basically to almost anything. So the focus really is for you not to commercialize a fraud detector, is to commercialize the core concept, which is in S1. If you reduce your problem to a computing domain problem, and then focus on S1, and that's where your innovation is, that's where your patents come from. Although you can have a patent here, but you could also have a patent in S2. But the strength really, you can patent the application domain. It's better to patent this one, because you can then see it being applied on all these other domains. Your patent will be important across all the various domains. So in our tech hubs, we should base our tech, whatever we take to the tech hub for manufacturing and anything, on the strength of P1 and S1. Right? That's where we should innovate. And tech, once we come up with this one and believe it's a very important contribution, that's where we want to commercialize it. When we apply to the various application domains and all that stuff. So it's much more powerful to do it that way. Right. I know that when you are always being told that your research, you don't do theoretical research. The fact that we are researching in computing domain, it does not necessarily mean it's theoretical research, because we will evaluate our solutions within the context of a practical application domain. That's the beauty of our work. But just because people are saying you need to solve problems in our country, it doesn't mean you need to shift your research and focus on P2. It doesn't mean that. I don't think they mean that. It's of course those people don't know. Not that probably they don't know that your research is in the computing domain. Do your research in computing domain, and then go to their whatever challenges they are facing, and apply your work there. That's what probably they are demanding. They are not demanding that you research on P2. They are demanding that when you get S1, apply it to problems in the country, the problems that we are facing. That's what that demand is everywhere. It's everywhere around the world. On all researchers, they are saying, when you come with this one, don't just say, we have come up with this one. Proceed to apply it to the application domain, and proceed from the application domain to commercialization and to create products, build factories, and so on. And that has been the case in computing since I don't know how long, since many, many years ago. Because we have DBMSs, they didn't arise from the application domain. They may have been inspired by the application domain, but they come up with a DBMS which is generic. You can store data in a DBMS. If you look at the literature for database management systems, which were created based on research, you will discover that they were researching, trying to solve problems in the computing domain. When they come up with S1, which is the DBMS, with all the, there are many of them around, relational technology, and some of it come from mathematics as well, because relational technology, for instance, is based on set theory in mathematics. And that's what they then applied to come up with S1. And then they created actual technology that you can use today, relational databases. And there are many other databases that are coming up today with also research in the computing domain. Graph-based databases coming from graph theory, application of graph theory, which then lead to graph databases, graph database management systems, and so on. And there are many other areas as well. But you see mathematics coming in as an approach to solving the problem that many people are facing in the computing domain, and then come up with a generic solution. And then, of course, graph databases are the ones that facilitate social networks technology at the moment. So it is important to realize that you, the drive towards patents, the drive towards research that solve the problems of the country should not change this diagram. In fact, this diagram makes it possible. It's an enabler. The approach presented here is an enabler to the Tech Hub. So when we go to Tech Hub, we present our problems. We present it in terms of this diagram to say we generally have this problem P1. And if we find S1, we should be able to solve a number of problems in various application domains. And the possibility of patenting is basically in S1. And the product that we can produce, of course, could be S2, but the core technology that is patentable is really probably S1. If you patent S2, then you see S1 can be stolen from you, but S1 is generic enough to be applied in many domains. That's where patents come from. And then, of course, commercialization also comes from S1, because you can create a generic component, a product based on S1, which can then be applied in all these other domains. So that is very important to consider. Right. I think I have exhausted all the possible discussions that I had in mind relating to this. I would like to welcome comments from both junior and senior researchers in this community who would like to add on to what I have said, or to take a specific aspect and critique it and enhance it and make it clear, so that the community, we can improve research throughout the community of researchers in the computing domain in the country. So we realize that the majority in our community are junior researchers, and they would need some level of guidance. The reason why we are in this community is because as senior researchers, we want to see a change in the productivity of computing researchers within the country. That change can be manifestable in many ways. First, the amount of research funding that you are getting is an indicator that the community is successful. The number of research outputs that comes, especially within the community, people collaborating is another. The indicators of collaboration is joint projects, joint funding, successful funding applications, joint publications, and generally an increase in the output of research across all the universities and projects that are undertaken by people from various universities. in collaboration. It's an indication of a community that is becoming mature. And you find that in mature research communities, especially in some of these advanced countries, projects are not done in isolation. Research should be done, it's richer and more productive when collaboration is at its peak. You cannot continue to have islands of poor small researchers locking themselves at their university and trying to look at research problems. You need to open up to become a community and to cluster around areas of interest such that people are aware of what is going on and people can contribute to the project. Some of those projects will become successful, right? Um, in our community, there are various interests. People should now start clustering around their areas, but at the same time, the areas sometimes are multidisciplinary. Some problems are multidisciplinary. They require solutions from even all these groupings within computing, because no one solution can be produced by only one group of interest groups, right? We need people in security, we need people in data modeling, we need people in data science, we need machine learning and all that stuff. Internet of Things, sometimes, for instance, domains like Internet of Things, we want to draw experts from all over the place who come together to create whatever is the product. So you cannot, at one university, just think you can work on your own and succeed. That cannot be possible. You need to collaborate as a community, and uh, pace for any research project is huge. Sometimes both P1 and P2 could be separate, could be projects that can be undertaken by probably the people in that domain who are experts. For instance, in agriculture, can join your project and then work on P2. And while they are working on P2, they will need CS1 in their solution. And so therefore, you can have parallel projects in this context. We have done projects like this where application domain experts are investigating P2 and computing domain experts are investigating P1, having been inspired by P2. And the two need each other, right? And normally funders want this type of thinking because you have application domain, computing domain people coming together and then solving the problem together. So sometimes P2 is massive enough in their application domain to require a PhD project. And then we already know that P1 will be a computing research project. So you can have two PhDs coming out of that, and one PhD requiring a component of the other, So that is very important to keep this project, this thing in mind. It's because you are not trained in the application domain, you may need knowledge in order to solve that problem. So sometimes you may think you can go and talk to them, but why not just get an expert in P2 who could then work with you to come up with S2? But that solution, S2, will be embedding S1 in it. So that is important. So this project can continue in parallel anyway, because there are many aspects of P2 that need to be addressed before you even can apply S1. So thinking like this allows collaboration, multidisciplinary, multi-institutional collaboration, which should be the aim of this community. We could be a community of people, including healthcare professionals, engineers, people in agriculture, people in healthcare. They are all probably allowed to come to join this community, mainly because of this diagram. Because of this diagram, we need both of them. And P1 and P2 could both be, of course, P2, we can't supervise projects in P2 because we are computing people. We can only supervise P1. So if you get someone who is an expert in the application domain P2, he needs a supervisor in their own area. So that's what produces technologies that can be applied. Even take the example of India, who have managed to create a rocket that goes to the moon. That requires a lot of experts from different areas. There is no product that can be produced by just one group. Maybe people only in computing never think you can do that. You can't do that. You need people who are multidisciplinary. And projects such as, for instance, going to the moon, creating a rocket that goes to the moon, and robots that do that's the stuff, require multiple disciplines and sometimes multiple institutions. That is important to work as a group and as a community who want to achieve something. So my motivation in this community is to change the landscape and create a community of computing. So it is up to you to play a role within that community to make sure that we succeed as a community and contribute something, change the quality of the community itself, so that so it's volunteer work at the moment, but it's important also maybe to reward those who put effort over time. You can't just be a community. It's unethical to be a community that depend on charity all the time. So over time, you need to have a community that is self-sustainable, that operates successfully, that rewards people who put effort, and of course, um, in that vein, I would encourage everyone to put in something, right? Creation of such a community which didn't exist before. I don't think we have a community in Zimbabwe for computing researchers. We are only taking baby steps. So each member, each one, everyone of you should put contribution. Your contribution could be comments on what is on research. It could be a research paper that you have. It could be a comment on these videos. It could be something that you share with the community. That's enough contribution. If you are always reading research papers, share with the community and see what you are reading, what you are thinking, and so on, so on. What you come across that may require research as you move around the country, and so on. So, because we are also in a baby step, we don't know, we have not developed, we have not bonded, we have not developed a culture of our own that is conducive for success. It is important to put your effort, contribute to the community. I see there is always silence on WhatsApp, on our platform. That silence could mean something, of course, but there's an effort that has been started here, which relates to our our creating our community, and that is very important for us as a community in the computing domain. For your own information, this is the only domain that is focused. That is very important, which the government even accept, recognize as important, and there is a ministry that has been established. It is a recognition that our domain is very important, but that ministry may not function if the computing research community is non-existent. So we are taking baby steps to first bond among ourselves and be able to be organized and be able to do research and produce something. And then probably we will then go to the ministry and say, we are a computing research community. We are organized. We are together as a body, and we can assist the ministry, the work of the ministry. We can assist in implementing its policies in the country and formulate policy that can help our domain to be functional. In fact, the country, the government, they realize that without computing, the country will not move forward. It won't move forward, right? But the ministry itself needs direction. The minister himself may not be a computer person. Even when Chamisa was Minister of ICT, he could only rely on people who have expertise. But if it's only an individual who is thinking to shape the direction the ministry can take, then that's a problem. So we need to be a community that is well bonded, that has direction, that is productive and active, And we do that by showing research. We do research. That's why in my case, there's no point in starting at a very high level. They already put structures for enabling our community. It's there. We have a ministry, just like the Ministry of Health, right? We have Ministry of ICT, and we are the community to drive it. And if we are not, we are non-existent. We are not together. We are not bonded. We can't be identified. Then there's a problem. But the first thing we need to do is to be there as an active research community. Then we can talk to the minister with direction, with confidence that we are a community. So that's why in my case I want to start at the grassroots, build the grassroots, and improve the quality of researchers, improve these things. And then we can leverage the fact that we have a ministry in that sense. So that's why I had this idea of let's have this community. I've asked even other colleagues, we are senior researchers, what should we do? What should we do? And most researchers are frustrated mainly because of lack of response on the ground in the country, lack of response. It have been, if you ask some of the people who know me, I have been struggling to contact people, to invite, to seek collaboration with people on the ground at most of the universities in Zimbabwe. And the response has not been that good, in the sense that, yes, at some point you do get people who come forward. We work together, we publish, we train a PhD to completion. We have at least an example where that has come out of these contacts I did with these universities, where we end up with some PhD student who studies and then complete. But it has been a constant effort. I've been thinking, how do I contribute? How do I contribute? How do I change the landscape of computing research in the country? So that's why we have this community. Of course, this community, in part, I would like to thank Caroline, who, with her staff at Manicaland University. The starting point, it was the starting point, but I have encouraged them to open up so that anyone else from industry, from other universities, so that we don't necessarily call it a Manicaland or whatever community. We want to call it a Zimbabwe computing research community, and use it as a base to get ourselves be present and felt in the country. And then we are a community which can do something together, and then we can have an impact in the work of the Ministry of ICT. And therefore, even in the tech hubs, we should be the ones to take over a lot of projects in the tech hubs. We can develop software, we can develop products that incorporate software product, Internet of Things. We can do quite a lot of things and be felt. We have the capability to change, even eliminate queues in the country. Right, we have that capability. Our area is critical to those issues of efficiency, issues of doing things fast, issues of, you know, facilitating almost every domain. We are at the center of the economy, so it is important for us to do that. And we start that by bonding and be a community ourselves. So that's basically what we are doing here. I am using this time to volunteer my effort as a way to contribute to this grand goal on a national scale. If you support that, then you would appreciate why we have this. You could promote it, you could grow it by inviting people and by participating and by doing your part in this effort. So this would be my appeal. So this video, I ended up present extending the discussion on the differences, on the computing domain, application domain problems, and how these two interact, how you should state your problem in terms of this picture here, and how I have also shown how you could state your problem and how this one promotes collaboration among from computing and other application domains and the possibility of collaboration. I then looked at how we can use this to grow our community and change the landscape of computing. And of course, I have discussed this also within the context of the current drive towards innovation hubs, towards patents, towards products that can be commercialized, research that can be commercialized, leading to products, leading to factories and all that, and employment creation. And I have, of course, touched on the community, how we can, the purpose of this community, and the fact that all of us should sometimes volunteer effort that is directed at growing the research community. And the fact that we have a ministry, we now have a ministry, that's significant in the country, right? That community cannot function. Of course, some individuals can be invited to formulate policy in the ministry, but the question is that the right policy? It should come from us as researchers. We can engage the minister, but we can only do that as a well-bonded community. If we can't work together, then there's no point talking to the minister, right? If we can't produce, if we can't publish, we can't, contribute to our area, then there is no way we will go to the minister saying what? What do you want to say? When you can't work together and produce something, there's no point in doing that. So, in summary, this is what this video has covered. Right. I invite anyone to volunteer effort, be active in the community, be active on WhatsApp, be active on the hour that we meet weekly. Record audio, record video, and post to the community, and so on and so on. I also encourage senior researchers to contribute aspects that you have expertise in form of a recording like this one. This recording is very simple. I just use vocal screen with a basic screen capture and a camera. I haven't employed a lot of time in editing this video or even in preparing for it. So it's a video that is made at low cost, right? I gave a link to you about the tool I'm using, which is vocal screen. You can do that for your lectures as well. It captures the screen. If you have a camera, you can appear, like in my case, you appear anywhere in there, and then you could, of course, cover. So I will be doing some of these videos, especially focusing on what I see in our community. In other words, if you don't present, I won't be able to make these videos. I'll make these videos after having seen something that makes me think, no, I need to have a video that explains this point. Right. So let's be active. Volunteer to present your ideas, your research. Even if you are working with a supervisor somewhere else, come and present your work. And sometimes you get stuck and your supervisor is not always available. So you may want other people's opinions. Research is about that. Your supervisor will encourage you to present at conferences. So just take it that way. It's like presenting at a conference, and you will listen to comments. Your supervisor, if he's a researcher, will not object to you presenting. If he is not a researcher and want you to lock yourself in your room, I don't think he will be thinking like a researcher. A researcher does not lock themselves in the room. You work, yes, but at the same time, you go to the community, to conferences, to publication in journals, and present your work to the world, and get their responses. Some people respond by reviewing the literature and commenting on your work. Some people listening to you at conferences. So this is the platform. This is the community where you can do that. Then I encourage junior researchers to also comment on other people's work, because everyone's idea is important. You don't want senior researchers only to comment. This is why if I were chairing these sessions, I want junior researchers to respond to this. We should have a buzz discussion on that. Just don't take it as if it's school. I'm not a headmaster. I don't have all the opinions that matter. You know, as a researcher, I know that we don't know much. We need to research, yes, but at the same time, you don't allow me to be the only one responding to a presentation. You also have expertise. You are lecturers. You have expertise in your area. Some of it different. So you need to bring in different ways of thinking, different responses. It could be questions, it could be comment, and so on. You need to rise up and make a live community. We need this as a way to promote production quality research in our in this community, right? In the next few weeks, I will also be starting more or less invite you guys, especially in the special interest groups, to work on something like literature reviews in particular area of like Internet of Things, computational linguistics. We want to do literature reviews and to expose the gaps, because we are just starting as a community. We need to say, okay, what do we know about a particular area? If it's computational linguistics, for instance, we want to start projects in our languages that involve our languages in technology. Let's do a literature review to see the current state of technology that could be applicable to our languages. And I would want to start those types of projects leading to a publication, a substantial publication we can publish in some of the reputable journals. So we need participants in that, serious people who want to work, who want to contribute, and so on. But with respect to building this community, each member is responsible to volunteer some effort. The effort could be to participate, be active, and also invite others so that the community can grow. And when we are grown large enough and we are in our groups and we have seen funding coming into members of our groups who are at various universities in the country in collaborative projects, and when we see publications rise up from all these universities, then we know our community is growing on a national scale. And then when we are bonded, we probably have met, and I'm proposing that we should meet at some point. We should organize where we all meet. For instance, I'm visiting Zimbabwe in December, early December up to early January. I will be in Zimbabwe. So I encourage, for instance, people at Mutare who are the majority in this community to organize an event where we can meet. We can meet and bond, right? And see what we can do in terms of actual research work. And when we have done that, we can proudly go we can proudly aim at influencing decisions and policies on a national scale. Because our community, we want it to have people from every university. So I would like to encourage you as personally to invite someone from a different university to come to this community, to be a member. Then we can have a platform. We can now even think of formalizing our presence on a national scale and say, okay, we are Zimbabweans, we are computing researchers. We own this domain in Zimbabwe. It's our area of work, and therefore we, we want to influence what goes on. We do have a minister and a ministry, and we can invite him to talk to computing researchers. Even if we can put 50 of us in one room, the minister will come and talk to us, and we will have something to say in an organized way. He will see that there is work going on, and so on. So if you organize events like this for only researchers, not students, but researchers, people with masters and above, we could have a mark in our area.